I'll give a small introduction, then you can start the session. Just,
all right.
Just small introduction. Okay, good. Okay, teachers, good evening. Welcome to the ESS Talk Conversation That Matters. Happy to see you. I know it's a Sunday. I know it's a family time, but I respect all of you time to coming and joining the session. And that's the reason why Santanu sir is here. Before I introduce Santanu sir, let's have an essential agreement for the next 2 hours of the meeting. I request everyone, please turn on your camera throughout the session. That makes a fruitful session. And also important, I need to take some screenshot. And then the session will be for 1 hour, 30 minutes, and it can extend for 15 minutes if we have a question and answer session. And please refrain from asking any question which is actually not related to ESS and IA Maths. And then please note, the session explains a mathematics using Excel and then technology, which will be Santanu sir is going to tell. And please raise your virtual hand and participate in the session. That's a very important. Okay, let me introduce the chief guest of the today, Mr. Santanu Bhowmik, Head of DP, German European School, Manila. He has 20 years of teaching, 15 years of teaching DP mathematics, and 11 years of the examiner. Teachers, I want to just 2 minutes undivided attention. Why Santanu sir? Why Santanu sir for this particular session? I have been working with Santanu sir for more than 7 years, but beyond that, I want to tell he is a man of a solution. He is a man of a solution. He was in pathways, he was actually first my CAS coordinator, IGCC coordinator, DP coordinator. I have been working with sir very closely. You go with any problem, teachers listen, you go with any problem, he will give the solution. And that solution is also win-win solution. Okay, if both the parties can go in a two-way, and both the parties will get a solution. That's a man of the solution. Okay, I have went to many solutions in personal life. Also in personal life, he is actually my guru. Many things, and professional life, he is a man of solution and professional. In fact, I was talking to my wife. If I get a chance to meet Narendra Modi, I will suggest him, Santanu sir, to include the Pakistan and Afghanistan talk, because these people are fighting, they don't get a solution. Santanu sir, you should go with any kind of the strategic talk with the Modi, with Afghanistan, Pakistan. Definitely you will give the solution. And not only for that, teachers, he is a man of creativity. You give a small thing and you will see the Santanu sir creativity today. You give any kind of thing, he always does in a different way. Teachers, one thing I want to tell, because when I worked, I and Santanu sir went on a global conference. I've been in Spain. It was a 5-day conference. That was my eye-opener, how you have to see your life. Santanu sir has a very professional life. At the same time, he has a very different personal life. How you have to take care of the family, that I have learned from the Santanu sir. And that's the reason, why actually I have called today Santanu sir to take the session. You will see why he is a creative and why he is a man of solution. I have many actually DPTs in mathematics, but he is the best person to give an excellent solution for the math, because we know we all struggle for the ESS Math. Who is the best person? Here it is, Santanu sir. Sir, here you go, sir.
Guru, all I can say is that's a lot of pressure with the praises that you have. Very generous one. Okay, so well, I mean, again, welcome everyone, and I feel very given this opportunity to go beyond the comfort of your own subject, things that you have been doing for so long. And I have to be very honest. For this presentation, I also had to revise, the theories, the concepts, brush them up. So I think I am already a beneficiary of this session before we actually begin. And then, of course, I had to learn a lot of things about ESS, because my understanding was it's one thing to come and explain you the maths, and which I do to my students. But since you are all ESS teacher, if I don't understand how ESS curriculum work, and especially this, you are here to help your students improve in their IAs and apply statistical analysis. When Guru says mathematics, it basically means statistical analysis. Then I realized that I can't just be teaching you the mathematics. It has to have a connection. So I had to go through the TSM guide, not TSM guide, the ESS guide several times, the teacher support material several times to understand what is required and what is not required. So the first survey that Guru sent you, where there was questions that do you want to learn mathematics by hand, like actual steps, or do you want to do it technology? So it was like 60-40 ratio. And then when I looked at this document, two documents, I was convinced that technology is sufficient to do that one. Okay. So what I'll do is, first of all, let me share this and begin with a little disclaimer that I always do. The disclaimer is that I'm here as a facilitator, which the term is very popular in IB world. And so I'm not here to teach you. We will explore what I know, what my understandings are. I'm going to share it with you, but you have to also do the fact checking. You have to also go and look into different sources. And I hope this is going to be an interesting journey for you in 1 hour that we have. But before we proceed, let's look at the result of the survey that I shared today. 26 response, not bad. Let's look at the first one. One of the mathematical requirement is solve simple algebraic equation for ESS equations for ESS student. So okay, around 46.2% of the people say that this is not true, because this statement is not available either in ESS guide nor in teacher support material. Okay, so moment of truth, it is there. This is in fact an exact quote that I have lifted from the ESS guide. Right, this helped me understand, okay, to what extent they need mathematics. Second question is, principal examiners advise students that or students should be encouraged to use statistical tests, which we'll see today. We'll see t-test and chi-square test to assess their data, but ESS guide and teacher support material has no mention of it. Okay, again, 53.8% people say that yes, that's true, but this is not true. We will see. It clearly explains in the TSM that students are encouraged to use statistics. So this helped me understand that whether really statistical tests are required or I should be focusing on something else. But again, as I'm saying in my disclaimer, please do the fact checking. Don't only rely on what I'm saying that it is there or it is not there. This statement is from ESS teacher support. Calculation of standard deviation is not a requirement, but it can be useful. True, this is absolutely correct. In fact, this is the exact quote from the TSM. Detailed steps of mathematics applied should be shown in IA to achieve. Of course, again, this is not true. Is I'm going to go with, because I couldn't find any literature, either guide, ESS guide or the TSM, where it clearly says let the students show the steps of how the students arrived at the answer. Most focus was on analysis and processing of data. But again, I can be completely wrong, but I have not found anything. So you have to do the groundwork again, go through those documents. Then student must not use online simulation data. I think unanimously everybody agrees that this is not true, which is also correct. And then sampling of data collection is as important as analysis, which I started saying, which I stated at the very beginning. And the statement can be found and this one. So what does it? This is true. Yes, of course, this is true. I mean, if you like today, you will see I have manufactured all data to make sense, to take the story forward. But it's very important how the data is collected and the quality of data. And statistical stats should not be done using technology. This is not true. Perfect. Okay. So we have clarified certain things and we understand where we are going to be. So in today's session, this is what we are going to do. Are you able to see my presentation?
Yes, sir.
Okay. So we already know the first topic is, this is our today's presentation's roadmap. So the first thing, what does IBESS document state about the use of mathematics? And then I'm going to segregate the keywords and put it into two, which we will see that it's largely about how well the students are collecting data, quality of data. And the second phase is then how well you process the data. And so what today we are going to do is we are going to investigate. And again, I have no idea even if it is closely related to ESS or the students or the students what they do in ESS IA. But I just picked this up saying that let's look at the effect of fertilizers and pollinating insects on hybrid metabolist flower and the different color flowers it produces. And we are going to investigate this through these four different kinds of mathematics. We will start with mean, then standard deviation, what is the use of standard deviation, then we'll straightway move to t-test, then correlation regression, and then we'll end with chi-square test, right? So that's going to be our kind of roadmap for today's work. So what are the mathematical requirements? In your ESS guide, it says that these are the things that an ESS students need to know. If you see, mostly like solve simple algebraic equation, one of the quiz that I lifted it from here, then basically in this one, I'm surprised that they haven't mentioned the statistical analysis or statistical tests are also required. So I carry on. So what are the keywords I picked from here? Plot graph, and interpret data presentation. Then your aim. So you have 9 aim in ESS, and I am picking and making informed decision. These are relevant to mathematics. And then you have 4 assessment objective. Fourth one is specifically for IA, and the keywords are the ones that I have highlighted in blue. So if and again, then in the ESS segment, these are a few more keywords that you can find. Look, quality of data collected, they have mentioned. So, and then out of all the ESS criteria that you have, this I found is the most relevant, where mathematics is required, where they construct, analyze, and interpret different things. And another one that I found, which is related to mathematics or statistical analysis that you're going to see, is the justifies the choice of sampling data, sampling strategy use, and risk assessment, which is, I think, in the concept of ESS. So if you take all the keywords, we can segregate all the keywords into two different categories. One is all related to sampling and data collection, and the other one is analysis and interpretation. And this analysis and interpretation is the focus of our session today, which is we're going to talk about standard deviation mean, how do you look at data, what do they mean, how standard deviation help you, then t-test, what is t-test for, correlation coefficient, and chi-square. And when it comes to the sampling and data collection, I'm going to just touch base on what you can find within ESS guide and TSM, and not really expand on that one, because that was not the focus of. But since data collection and error and everything is associated with statistical analysis, therefore I thought I'll mention it here. So this is what your TSM says. It talks about quality of data. So you have to also, when you talk to students, you have to also see that quality data is done, and then they also require to explain their sampling strategy, how they are doing it. Primary data collection is perfectly fine. Even secondary data collection is perfectly fine, which was a breather for me because I manufactured a lot of the data that we're going to do today. These are the data collection methodologies. These are all from the TSM guide. Again, this is related to data collection, that the secondary data collection works perfectly fine, which is also relief of sight for all the students who are not online. Like my school, we are not online since last 1.5. I mean, we are online since last 1.5 year. These are the different sampling methods that you can look at. I have also shared a link where you can read this blog. Very nice, very simply well written, and the students should become aware about it, and they should also kind of write when they talk about their data collection methodologies and the quality of data and describe their rationale. Um, so finally, analysis and interpretation. So the guide clearly says, the TSM clearly says standard deviation is not a requirement, but we're going to see how standard deviation helps. Then it also gives you a direction about the quantity of data you should have. So which is for manipulative studies, you should have 5 measurements. So please read through it so that we have enough data when you process things. And this is the most interesting part. They have the TSM has a clear about statistics, which they are saying that the students should be encouraged to use statistical tests. And I don't know why they haven't mentioned it in the guide, but yes, it is a known fact. It's not just that principal examiners are saying, it is a written statement which is valid. Please check again and don't rely on me. What else we could do? These are the things you can also do, which we are not focusing today, right? So we will be focusing today, what I said, we'll begin with very simple mean. Okay, let me now share my Excel sheet. Just a second, give me a second. All right. Can everybody see my Excel sheet?
Yes, sir.
Is this big enough?
Yes.
Yes, we can see.
Yes, sir.
Okay, great. I probably, if in some Excel sheets, I can increase the. All right. So what is the investigation in hand? So it's easier to understand the mathematics when we have a task at hand. So let's say we are trying to find out what how fertilizer A and fertilizer B impacts the growth or the number of flowers this particular flower produce. Okay, so let's say you have, these are all growth of plant. Let's say once a particular student is trying to do this experiment, he observes that all these heights for around 11 different plants, different set of plants, and this is height which are used, the fertilizer B, which is used in a different set of plants, okay, is their height, okay, growth in, I think it should be centimeter, okay, but anyways. So how do we calculate mean? Everybody knows, but I'm just going to show you how you can do it in Excel sheet. So all you have to do is very simple. Everything that you do, remember this taskbar, and don't forget to put an equal sign. After equal sign, then okay, we are trying to find out average. So if you just type out AVG, it will already give you the average. So if you double click on average and select all of this here,
Sir, can you enlarge it? Shantanu sir, please enlarge it, sir. Some people are wanting.
Okay. All right. So similarly, let's say what we need to do, we find out mean. So we say average. Another way of going into this one. So if you don't want to remember equal sign and this, so just look at this FX sign here. It says insert function. So you click here. Then you will see all of this option that you need to choose. So we'll choose statistics here. And you will see the second option is your average. So once you click, it then automatically asks you, what is it? So here, okay. Oops. Okay, so I need to select all of them, right? So we got the mean of this one. What does the mean say? We all understand what mean, how to interpret mean. So it means when you use fertilizer A, the average growth is 16 centimeter. Okay, and for fertilizer B, the average growth is 14.5 centimeter. So one can easily say that fertilizer A is more effective than fertilizer B. Okay, so if you just look at this way, so why do we need standard deviation? We need standard deviation to see, is the mean about this particular set of data, how consistent it is. Are there many outliers, or this mean is a true reflection of what this data is? Okay, to expand more on it, let's look at this one. Same set of data. Okay, same set of data. Now what I have done is, so for fertilizer A, now I have calculated this standard deviation. Process is the same again. So let's say we want to calculate standard deviation S. Okay, we go to function and go to statistics, and then type out, if you can just scroll S, look for. Now you have two functions, stdevp, stdvs. I'll explain a little later what are these two differences, but let's say we are calculating this. Okay, done. So we got the sample standard deviation as this one, and we got the population standard deviation as this one. Okay, so we will look at the idea of population and standard deviation, but let's just conclude the analysis of how this mean can be deceiving. Now, let's, for the time being, focus on only this one. Okay, let me put it in red. Okay. Now, if you see, all right, so when we were just looking at the mean, we said, okay, fertilizer B is more effective. On an average, the growth of plant or the height of plant is 16 centimeter. And fertilizer B is not that effective because, you know, it's less than 16, of course, 14.5. So there is a difference of 1.5 centimeter. But now if you look at the standard deviation, you see the standard deviation for sample A, fertilizer A, is 8.9. It's almost 9. And standard deviation for fertilizer B is 2.9, which is 3. So a huge difference. What does this mean? It means this data A or fertilizer A is not consistent. Now, if you want to understand it, look at this one. You can also see, because it's a small set of data, you can also see the inconsistency. So when you apply fertilizer A, some plants like 3 centimeter only, some are 4, some are 6. So there is no consistency in the sense that, okay, yeah, you apply fertilizer A, and then you can be sure to get a particular growth. Whereas fertilizer B, although on an average it gives less, height or growth, but it is more consistent. So you can rely, it is more reliable, fertilizer B. So you can, on an average, you can expect 14 centimeter growth. So, and if you investigate further, look at the data, you see, yes, they are like 10, 11, 12, 13, 14, 15, 16. They're around that mean. But for fertilizer A, look where the mean growth is, which is 16, and where some of the growth is like 3, way away from the mean growth, right? So this standard deviation helps you decide whether the mean is a true reflection of the data or it has inconsistency. You can check the reliability of the data, like in ESS IA. One of the things the student needs to do is provide solution. So let's say if the student is doing this one and wants to advise the farmers of this particular plant, then they need to convince the farmer and say that, look, I think if you use fertilizer A, there is a chance that you will have better growth than fertilizer B, but be very sure that it is not going to be as consistent as fertilizer B, because fertilizer B is more consistent. So if you want more protection and if you want certain kind of growth, then go with fertilizer B. So that's how your standard deviation helps you, and it gives you a perspective or context to the mean, right? What else student can do to check the consistency of the mean other than mean? Because mean is very rudimentary and it gives you a very fake idea of what's happening in the data. So you can do this something called box whiskers plot. Okay, again, how do you do box whiskers plot? And I'll explain what box whisker plot is. So in Excel sheet, you can go to insert. The moment you click insert, then you will see a lot of the graphs appearing. So you go for you go for okay, so fertilizer A. I want a box plot for this fertilizer A because I want more information about how consistent these are. So I'm clicking here and I'll go to all chart, and if you see box whisker plot, okay, so I plot box whisker plot here. This is fertilizer A. Okay, then here I need to put it a bit here. The students can do more analysis to confirm their understanding whether fertilizer A is more effective or B. So they can find out the maximum of the data. So this is fertilizer A. So what is the maximum height? 34. What is the minimum height? 4. What is the range? Range is the difference between the maximum and the minimum. So again, it validates that the fertilizer A is not a consistent fertilizer, because some plants are as low as 4 centimeter in height and some are as high as 34. You can do the same thing a little bit more. So you can check the quartiles. So what are the quartiles? So if you look at this one, this is called lower quartile, this one. Yeah, lower quartile is 6. How can you find out lower quartile? Again, the same thing. You have to just click here and pick the lower quartile function. So just go to, let's say, here, start with Q. So it's a Q quartile.exe. When you click, it says arrays. That means where is your data? So this is my data. Then it talks about which quartile. So you say, I want to look for first quartile. First quartile means median is half the data, right? Median means half the data. Where is the middle data? And lower quartile or quartile 1 is where is the 1/4 data. And upper quartile or the quartile 3 is where is the 3/4 of the data. So you just choose 1 here. Okay. And it gives you lower quartile is 6, 16, 23. Median you can find out like that and thing. And then what is IQR? IQR is the interquartile range, which is 22. Now look at your range, which is 30. Look at your IQR, which is 22, and look at your mean. They are like very different, right? Again, tells you that this is inconsistent. Whereas if you look at fertilizer B, then you see fertilizer B, look, the range, the maximum height is 20, minimum height is 10, the range is 10. Interquartile range is 16, which is also reflects or close to the mean of the fertilizer, which is 14. And this again tells you that as compared to fertilizer A, fertilizer B is more consistent, more reliable. So if the students just looks at the mean, they are only going to give you a lateral justification of what it means. But if the students then considers the standard deviation, like how the data are deviating from the mean, more they deviate, bad. More they are close to the mean, that means yes, it is consistent, it is more reliable, right? And then the mean means it is giving you the true picture of the data. I'll give you a quick example. If you have in a room, if there are 2 people, and then I say the average age is 50 years old in that particular room, most of us will get this idea that, you know, people of age 50 years are there, 50 years old. But what if In that role, there is a grandfather and a grandchild, maybe 92 years old and 8 years old. Average height is 50. So, but if you did the standard deviation, you'll see that the standard deviation is high. That means not reliable. Mean is not giving you the true picture. Okay. Right. So this was your standard deviation and mean. We are now going, before we go to t-test. So why do we use t-test? We need to spend a little time in understanding something called sample. And we will also understand hypothesis. Okay, just a second. All right. So statistical testing basically means that you want to check some hypothesis. So we first have to have an understanding of what is this hypothesis testing, or why do we call them statistical tests? Today, we are going to see t-test and chi-square test. So in the investigation that we are doing is like effect of fertilizers on the growth of this particular flower plant. So if you have the whole garden, that's your population, that's your thing, right? You can have a huge garden, but it's not possible for all of us or anyone to take data of the entire garden. So you choose a subset of the entire garden. So you choose some plants only to observe and get the data from. So that's your sample. So when we talk about hypothesis testing, it is basically that looking at the sample, you are trying to make a statement about the population. So hypothesis testing is not about the data that you have. Okay, it is about the data that you have, how you can use that data to make a statement about the population. So that you are convinced that yes, by and large, that's what happens. Okay, based on the data that I have. That's hypothesis testing. So there are kind of 7 crucial things about hypothesis testing. The first thing is this hypothesis testing is used when you want to make a statement about the population based on your sample, which I said. So it's not about the data that you are dealing with. It's about, through this data, what can you talk about the population? Does the data show significant difference or significant dependence in the population also, the whatever in your investigation, or it is only limited to your particular data. Second two is always about population parameters. Third is it is not about sample statistics. So the sample that you deal with and apply the statistical test, the outcome is not applicable to your sample. It's applicable to your population. So we need to keep that in mind. And then you always need 2 opposite statements, which are called hypothesis, the plural of hypothesis. One is called the null hypothesis and the other one is called the alternative hypothesis. So what is this null hypothesis? It's standard, irrespective of whether you are doing t-test, chi-square test, or any other test. Mostly null hypothesis considers that there is no effect, there is no difference, or there is no independence, or there is independence, in other words, right? And you then also state an alternative hypothesis, which is just opposite the null hypothesis. What does that say? It says this statement assumes or says that there is difference, or there is an effect, or is not independent. That means dependent. Okay. And then how do you really go about doing this testing? Precisely 5 steps. First is you have to state your hypothesis. Then 2, you have to decide your significance. 3, of course, you have to have your sample. You have to process sometime your sample, suitable, make it suitable for testing. Then you have to calculate the p-value, right? That's where we are going to use the technology. And 5th, based on your p-value, you will make the final decision or try to make a statement about the population, not about the data that you have. Okay. So before we move about this hypothesis, let's spend some time in understanding this one, the second one that we said here, which is what is significance level? In between, I just wanted to take little feedback. Is my pace okay? Too slow, too fast, or anything?
It's perfect.
Appropriate,
It's okay,
sir.
Very good. Yeah.
Okay, thank you.
Yeah.
Thank you so much.
Thanks, sir. So going good. Thank you.
Thank you. Right. So let's understand what is this significance level and what is this whole hypothesis testing about. Okay. If you are biology teacher already, and I'm sure if that applies also to ESS, pure ESS teacher, you must have heard something called normal distribution. This is like mostly found in nature. What does this normal distribution mean? If you look at the curve, this one, this curve we have. So this is a typical normal distribution curve, right? What does this normal distribution mean? It's any distribution where you have a mean and most of your data will be either more than mean or less than mean. Then it is a normal distribution. Okay. For example, the fertilizer A data that you saw, the mean was for fertilizer A 16, and there were some which are less than the mean and some are more. Some are very less for fertilizer A, 3, 4, and some are very high as 34. Okay. So what does normal distribution say? It is, again, you can spend one session only to talk about normal distribution, but roughly I'll tell you, the mathematician on the statistician, they figured these things out, and they said that, look, anything which is normally distributed, you will expect, let me see if I can use my digital pen, Epic pen. Okay, let's see. Okay, I'm going to try to write something and tell me if you can see what I'm writing on the graph. I just made a circle. Do you see the circle?
Not yet, sir.
Okay, hold on. That means I need to share my entire okay, so how do I go about it? Show, no, okay. Okay, maybe now. Can you see now I'm making a circle? Oops.
Around what?
Do you see a circle
Yes,
now?
yes.
Everybody?
So very much, very much. Yeah.
Yes,
good.
sir.
Good,
Thank
good, great. All right. So as I was saying, what happened is anything which is normally distributed, any data, you can assume that whatever the mean of the data, most of the data. So if you add this, these are all probabilities that you see here. Okay. So around 68% of the data will be very close to the mean. And if you even consider this, you will see around 95% of the data will be within this distribution, which is 2 standard deviation away from the mean. Okay. That means if your mean is let's say if your mean is 16 and if your standard deviation is, let's say, 2, that means they will be, or everything will be distributed like 16 minus 4, which is 12. So everything will be between 12 and, oh sorry, this should be plus, so it should be 20 and this should be 12. So between 12 and 20 you will get most of your data. That's the whole idea of the significance level, that you understand that if anything is normally distribution, most of 90% of the data will be within this range. Okay, and then you see rest of it rest of it is outside. These are like data which are outliers here. From here onwards, they are 5%. So these are like 2.5% and 2.5%. That consists of the total 5%. 5%, and rest 95% of the data is here. We need to remember this, because when you do hypothesis testing, this is a key decision that the student and anyone applying the hypothesis testing needs to keep in mind. So you need to decide what is your significance level. In other words, when you are investigating effect, let's say effect of fertilizer A and effect of fertilizer B, you are deciding that you want the effect to be 90%, 95%. You are not going to be, you are not accepting it below 95%. And again, when I say you or I, it really doesn't matter to you and I, because scientifically, in the scientific world, 5% significant level, 0.05 or 5% significance level is considered as reasonable. You have other significant levels also, but as long as your probability is 95%, you are good to go. If it is less than 95%, you reject the notion, which we are going to now see. What is the notion that we reject? So if we just move to t-test straight away, okay, let's look at the hypothesis. There are 5 steps that we talked about, okay. So let's say this is our data, and the experiment is whether there is any effect of fertilizer A and fertilizer B. So, you know, in t-test, you have something called whether the t-test is paired.
One tail.
Whether t-test is paired or unpaired. Okay,
Is the
these are
same
the
as
t-test.
2 tailed and 1 tailed?
Sorry?
It is the same as 2 tailed and 1 tailed?
No. The other one is 1-tailed or 2-tailed. Okay.
So both
These are the
different.
two. These are the two aspects. Okay. So let's first talk about paired or unpaired. Okay. So what does paired or unpaired means? If you look at our data, fertilizer A and fertilizer B, and as in the beginning I said that these are different sets of plant that you apply this fertilizer A, and fertilizer B, different sets of plant, right? So there is no difference, there is no connection between plant 1 and plant 2. So if you selected 11 plants and applied fertilizer A, you had another different sets of plant on which you applied fertilizer B. So this is an example of an unpaired data, right? Let me give you an example immediately of a paired data so that you know, our understanding is clear here. Hold on. All right, this one. Now let's say anyone conducting a third experiment. There you choose 11 saplings, and first month you don't apply any fertilizer. And in the second month, then you observe the growth without any fertilizer. Then in the second month, you apply the fertilizer on the same saplings, and then you observe the growth again. This is an example of a paired data, because you are applying the test or the experiment on the same object twice. Is the idea clear of paired and unpaired?
Sir, is it like having a control and then experimenting?
Well, if you want to talk about control and experiment, let's say, yeah, in this case, let's say no fertilizer means, no control. Control means you applied fertilizer B. But what is you have to see is that, are you doing the same thing again? For example, here, whatever plant number 1 you took, that plant number 1, in the first month, you observed it without any control, no? But then on the same plant, you apply the fertilizer and then you observed again. So it's the same plant's data, first data, second data. Let's take another example. Let's say, let's look at our class tests. So you give a class test.
So there's a doubt for one. Leena madam, go ahead. Leena madam.
Sir, actually, I have a doubt in this controlled. When we are looking into different variables, controlled variable means in a set of experimentation. We are doing one set of samples where we are not using anything, right?
Yes, yes.
So that will come in the first one, right? No fertilizer we can call
Yes.
it as a control also, right?
Yes, yes. Yeah, I'm not familiar with the technical terms, but the idea is that, as I was explaining, let's look at the class test. So let's say at the beginning of the academic year, you give a class test to your students, let's say 10 of them, and you see their score before teaching. Then you teach them and give the same test to the same set of students, and then see what they score. And then you want to see if they have improved. So this is an example of paired data. Does it make sense now?
Yes, sir. Yes.
Yes, sir.
Yes, sir. Yes.
Right. Cool. So another thing is one-tailed or two-tailed. So one-tailed or two-tailed comes in effect when you are kind of trying to make the hypothesis. Okay. So in this case, what we are trying to observe, we have 11 plants on which fertilizer A was applied, and we checked their growth, and fertilizer B was applied on a second set of plants. They have no connection, so they are not paired, unpaired, and we observe the height. Okay. Now, let's say if you want to hypothesize that there is no difference between the mean, that's like the pure technical term, and of T test, and H1 is like there is significant difference between the mean. What you are basically saying is that in this particular context, you are saying there is no difference of fertilizers. So if you make a neutral point, that means it is two-tailed. That means it can go in either direction, right? Either direction means, let's say, as opposed to this one, as opposed to this hypothesis that we just created, where we are saying there is no effect of fertilizers. Okay, let's say this was our null hypothesis. This is two-tailed. Why is this two-tailed? As I said, because you are making a neutral statement, as opposed to, let's say, if we say fertilizer A is effective than B. Now you see, you are putting the weight to one of the fertilizer. And that's why it is one-tailed. Let's understand this with this graph that we saw, which was here. Okay, so the one that you see in the middle, that's the graphical representation of what a two-tailed presentation is, or two-tailed data is. What is that? The middle. Do you see two tails here? Literally, this is tail 1, this is tail 2. Remember, little while ago, we said we want our data to be 95%. Okay, so that means in this particular context, we are going to say that we are going to make a neutral statement. We said the fertilizers has no effect, or the fertilizers has effect. We are not saying whether A has more effect or B has more effect. In this case, this is a two-tailed one. You are not prejudging or you are not pre-deciding. What is one tail? One tail could be this one and this one, where this will be 5% and this will be 5%. If you say A is more effective than B, okay, then you have one tail. And if you say no, B is more effective than A, then you say, well, that is another example of one-tailed data. So normally it is, unless your experiment or the student's experiment, requires it. So safest bet is that you take two-tailed data, because you're making a neutral statement and saying that fertilizers have effect. So A can have effect, B can have effect. You are not prejudging them. Then you can do further analysis and see which one really has an effect. Does that make sense? About one-tailed and two-tailed?
Sir,
Yes.
sir, can I go?
Yes. Yes, yeah.
So does that mean that we have to, for any data for that matter, we have to conduct a two-tailed test and then go for the one-tailed test?
No. Again, this is where your ESS teacher ideas will come into place, because you have to then look at the data, and you have to look at, like, for example, whether height has any relation with weight of a person. So there, the student has to see in the ESS context subject knowledge, is there an effect? Then the student can always say, tilt it towards a particular, no, height has more effect, height has effect on weight, no, weight has effect on height. Or you can make a neutral statement saying that height and weight has no effect on a particular thing, which is two-tailed. So you have to look at the context, you have to look at the data, and then you can decide, okay, maybe I will check for whether A has more influence or B has more influence. So you can use both, not a problem. But that will depend on the data that you have and how you can go towards it. So right now what I have done is I have taken a neutral statement. Then as we proceed, you will see how we are unlayering and trying to find out which one is more effective. Okay.
I have a little confusion.
Yeah.
Can I ask?
Yeah, sure.
So you said about the two-tailed. I mean, usually we have a hypothesis, right? And our hypothesis usually states what is going to be the outcome, right? There's a presumption which we take. So a two-tailed test is when we are presuming that there is going to be a difference.
Yeah, that's what I'm saying. You are prejudging it, then you make that statement. But if
when
you're
you
not
actually know there is going to be conducting the experiment only because of the fact there is going to be a significant difference.
Yes.
Right. When you're not sure, then you do a one-tailed test.
Yes.
If this is how I have understood.
Yeah, you're absolutely right. That's what I'm saying. This will really depend on your context, what kind of a data you have, what kind of an experiment that you're doing. And if you already want to believe or think to say that one, definitely have more than, then you make it a one-tail. But if you want to make a neutral and see whether it really does have or not, you want to figure it out, not very sure, then
no, that's what I'm trying to say, sir. Like, since you've already done a hypothesis, your null hypothesis and an alternate hypothesis is already there, right? So
yes,
the two-tailed test has to go along with your hypothesis. Correct me if I'm wrong, sir.
No,
because
it's like, hypothesis will always be there, whether you do two-tailed or one-tailed. And it is going to be always, you have to take a decision whether it is paired or unpaired. But the thing is, the decision whether you are going to do a two-tailed one, if you want to make a neutral statement and then see what the result says and then make a decision.
No, that's precisely I'm trying to say,
yes,
sir.
Yes.
Let's say we have an experiment about whether fertilizer A and fertilizer B have any difference. So in
Yes.
our thing, we experiment, we give a hypothesis that yes, fertilizer A is going to be more, let's say it's an organic fertilizer, it's going to be more, sorry,
Yeah.
let's say,
Yes. A perfect example. Maybe an
yeah,
organic
organic,
fertilizer. Yeah.
inorganic, whichever we have taken is
Yeah.
going to be more effective on this. So this is
Exactly.
the hypothesis we've already given. Now the student has to put a statistical analysis to prove that this hypothesis, which he or she has predicted, is going to be true or not.
Yes.
So that's how
Yes.
you
Yes.
already decide that this is going to, because you have an outcome already in your mind.
True. True.
Yeah. So in case the student has decided that, okay, this is there is not going to be any difference, that's the student's hypothesis already, then he has to do an one-tail test.
Yes. So
I
when
can be
you
wrong
do and
also,
what?
sir. So
No. That's what I'm saying. You're making perfect sense, and that's how you write down the hypothesis will depend on which tail one you are saying. This hypothesis, where this says there is no effect of fertilizers, this is neutral. So this is suitable for two-tailed t-test. But if you want to do one tail, you will say there is no effect of fertilizer A. And here you will say there is significant effect of fertilizer A or B, whichever you have more evidence about or whichever you are sure about. So if I change this hypothesis to this, then I'm going to conduct a one-tailed t-test.
right, got it.
Yes. But if I go back to the hypothesis that we said, which is neutral, it's not talking about, it is not taking sides of fertilizer A or B, neutral, then it is two-tailed. Is this okay?
No, that's not okay, sir.
Okay.
So may I retract what I was saying is the fact that we have a hypothesis. The null hypothesis says there is no difference. And the alternate hypothesis says there is a difference. That's the statistical test. After doing the t-test, we will come to infer. Right. But in the environmental issue, after the environmental issue we discussed, we have a hypothesis which is already stated by the student. Right. So if the student states this, he's going to test the null hypothesis or the alternate hypothesis, like there is a difference or not, there is no difference. So he has already decided, because there is something called scientific justification to your hypothesis. So the student has already decided there is a direction to his experiment, that yes, in inorganic fertilizer are going to be more effective in the growth because they have certain essential excessive nutrients in them. Right. So that's where, because your two-tailed test or one-tailed test has to go along with your hypothesis, whatever you have predicted already in your hypothesis.
I think I don't know. Essentially, I think we are both talking about the same thing in different ways.
Okay. I know because see, I'll tell you why. Because you said alternate hypothesis, there is no effect on fertilizers. That's fine. But if the minute you put fertilizer A is going to be more than fertilizer B, then you are actually not taking the right direction. That's why I got confused.
Oh, okay. Yeah.
Sorry, can I ask something as well whenever there is a chance?
I'm good. Thank you so much, sir. Sorry to interrupt.
No, it's perfectly fine. Yes.
I just wanted to bounce off what you said about the fertilizers. So is it possible to do both? First, a two-tailed test to determine whether the fertilizer in general is effective compared to the growth control experiment, and then do a one-tail to determine which of the fertilizer.
In the ideal world, in an ideal scientific world, it is advised that you first make your hypothesis, use your data, see what the result is, and then accept or reject. And it says that don't just take the data and do lots of things and then figure out which way you have to go, which a lot of the students does, and look at that thing. So I won't be able to give you as a statistician, as an direct advice whether you should do or not. But I personally, if I'm playing with data and I want to figure out, why not? It's an Excel sheet, put data, see which one helps, which one doesn't help, which one tail says, what two-tailed says, and then draw conclusion. Yeah.
I guess, sir, there is a subject difference. Guru sir will be able to say that, because in ESS we already go along with a prediction. That's why it is, this direction of two-tailed, and there's a prediction which we are trying to prove, right? Because that's what the context of your, investigation.
Okay.
Yeah.
So
for you is for a maths, like maybe some other subject, we go with, okay, maybe trying to manipulate, okay, but this one is correct or that one is correct. But here we actually go with a mindset, okay, we are going to prove this. Sir, Guru sir, if you can always correct me if I'm wrong.
Yeah, if a particular test, yeah, perfectly fine. Thanks for your input. If a particular type of test or one-tailed or two-tailed is more suitable to ESS, please feel free to use that one. So not a problem.
Sir, I have one question. I may be wrong. Actually, no, when you are talking of pure mathematics or pure statistics, meaning this is what I feel, I don't know, I may be wrong. At that time you stick to this two-tail and one-tail, because actually it is pure maths or pure statistics. But I think, I don't know, in biology, what the same I apply for ESS also. You have a hypothesis where you have two options, one is null and the other. And whether it is true, whether your hypothesis holds true depends on your critical value. So what I want to know is that, is it really important to differentiate between this two-tail and one-tail for natural science experiments?
I think the previous participant who was explaining about that, I think what she was saying is right, is that it really, if you say that you have more like organic and non-organic fertilizer, so if you already have a bias or more confidence towards a particular fertilizer in this case, then you are already taking kind of sides, right? So you then have to make a one-tailed t-test. But if you're not sure, that's my understanding. But if you're not sure and you want to see whether there is a difference or not between two fertilizer A and B, then you do two-tailed one.
Sir, can I add one thing? Can I add?
Yeah, sure.
Teachers, actually, yes. Absolutely fantastic question, but you have to understand one important thing, okay, as an examiner point of view. Please always note, after the particular IA, our students, after submitting the IA, our students is not going to get a Nobel Prize or Oscar Award. Fantastic. Okay, this is an excellent IA. Come on, take a Nobel Prize. Come on, take the Oscar Award. So we are putting a lot of pressure. And do remember, the students have another 5 IA also. In my case, last year I had 65 students. Okay, I have given the statistical based on the students' potential. I will not give everything to all the 65 students. So you have to see which students can do. Take, for example, in my class, there are 10 to 15 students. They have a thirst of the 8 point, even though there's no 8, but they have a thirst. They don't actually depend on the 7. They, after my life, say, I want 8 too. Those, the students challenge you, give this kind of setting. Take, for example, there are some students that don't care about anything. They say, sir, I have a big family. I'm going to take care of my father's business. My Nani house is near to Salman Khan house. My papa is a friend of the Hrithik Roshan. So I don't care. So that's all. I just give mean more standard deviation. So it's all depend on your research question, your students. So that you please keep it in clear. Thank you, sir.
Yeah, Guru sir, can I say something? Archana here.
Ma'am, yes, ma'am. Yes, ma'am.
Yeah, so what Mr. Shanmu is saying, and as ESS teacher, we need to be careful that our thrust of the IA, of any IA, is not the hypothesis testing. It is the analysis of the data. So whether you pick up the two-tailed analysis or not, or you go by the null hypothesis, makes sense with the students when you clarify in the beginning itself that most of the IAs in ESS are not the kind of that there they have to test the hypothesis. Somewhere if you want to push that student who has the capability, then you suggest for going for the T test or not. But normally our students ESS, I have seen that they are okay if they find out the correlation and causation. If they are getting it right, then they are placed on higher mark band. So that's enough for us. So what somebody else was also asking that whether to have detailed test prior, that depends on how you word your hypothesis. So that matters. So as ESS teachers, we need to be very careful with whether we want that our 95% of this data is kind of falling in the hypothesis regime. If 5% is outlying, so what kind of variable is affecting that? We need to perceive it beforehand, and if there is a capability within the student, you can push for the testing, t-test or even chi-square test. That is what I handle ESS data set.
I agree. Sir, please go ahead, sir.
Right. Yeah, and I think that is the reason why in the guide they haven't mentioned that statement that the students are encouraged to test their data. They mention in the TSM so that the teacher can decide who to encourage, which student to encourage for this kind of testing, and which students should be just fine with correlation and mean, standard deviation. If I highly recommend to also look at the standard deviation, because we already saw we can go in a different direction if you just look at the mean, right? Okay, so step one.
Just a question.
Yeah, sure.
Sir, just keeping the mean, like where people are comparing how the soil variety changes the plant growth or how the salinity affects the plant growth. I think so mean should be sufficient enough for them, or do we really need to add the standard deviation or the correlation over here?
See, again, you have to look at the data, right? The data that you have. And if you, like, for example, the first one that we took, growth of plants when fertilizer A was applied and growth of B when fertilizer B was applied. I mean, as a maths teacher, I always recommend students that when you comment on mean, do look at your standard deviation, because if you don't look at your standard deviation, what does the standard deviation say? Basically, the standard deviation shows you the mirror of the data, or gives you the inside story of what's happening inside the data. We have only 11 data, so you can clearly see, when you apply fertilizer A, some plants are as low as 3 and 4 and 6 centimeter high only. So literally they didn't have any effect of this fertilizer. And on some, they had very good effect, which is 24 centimeter, 34 centimeter. Then this is not a, consistent, this is not a true picture that on an average, the height of the plant would be 6 centimeter if fertilizer A is applied, because this data is full of deviations. That's what the standard deviation really means. How are the various data deviating from the mean? And more they deviate from the mean, that means it is not a consistent one, right? So I would suggest that before commenting on mean, look at the standard deviation. If the standard deviation is very high, then it is not a reliable picture. Then you need to resort to something else, maybe another experiment that you have to decide as an ESS teacher. I hope I answered that question.
Okay. Sir, just to add over here, because you've only considered how the height is going. So like in my case, if I say my students, they look at the fruit, the leaf size. So we've multiple variables that they look up, they're exploring over there. So even in that case, you believe, but then again, we don't have those number of values. So generally the data will be spreading over 5 weeks. So each week they will be measuring the height and the difference that is present over there. So do you think we will still be having sufficient data to put the analysis to run any other analysis rather than mean?
Look, if you have very small data, like I have 11 data, you can then look at the data and say whether it is consistent or inconsistent, right? But if you have a large data, and for t-test and chi-square test, you need large number of data. Then it is not possible for you to look at the look at the mean
to apply
and
any
talk
statistical
about it.
analysis because the values are very few to put the number.
Yeah, true. So for t-tests, you need more than 10 data. Otherwise, it's not going to work. For chi-square test, you need around 50.
The surveys that we're doing can be actually applying the t-test. We can use them, but for the as in the experimental part, we can actually keep with the mean and the standard deviation in itself.
I didn't get that part. Sorry.
So the question we're doing the surveys because we have actually like around 30 samples for us. The survey analysis jo hota hai.
Right.
So keeping that in mind, we can actually run the t-test on those.
Yes, yeah. I think 30 to 50 would be also good for chi-square, but then when we talk about chi-square, we'll see the loop falls.
Chi-square falls in a little technical more because the students I have, they're just taking SL maths, so then comparing that gets a little tedious for them.
Yeah, you have to see the context of the school context, student context, how much one can do, what kind of data you have.
Yeah. Thank you, sir.
Welcome. Anything else on data or mean?
No, sir.
Okay. Right. So we have 5 steps for this hypothesis testing for t-test here and then chi-square later. So you state your hypothesis, whichever is applicable to you. If you already have more information, there is a affinity towards a particular factor, then you can have one tail or you can have a neutral one, two tail. Then you have to decide on the significance level. There are 3 standard significance levels, which is 10%, 5%, and 1%. Usually people take 0.5, which is like the 5%. That means you want 95% of the things to be the probability to be in that around mean. Otherwise, it's not going to work. And step 3 is going to be, you take your sample that you need, okay. And step 4 is the time where you actually calculate the p-value. So remember, when you do Excel sheet, you will get the p-value, not the t-value. T is the t-test where you apply the formula and you get a t. And it then is very complicated because you have to look at the critical value, degree of freedom. But if you find out the p-value, which is the probability, which tells you the probability of this data being in the 95% area or not, or what percent of the area, or what is the difference area, then it's very simple. And how do you apply a t-test using statistics? It's again, let's say we don't have it here. You go to include function, statistics, and just look for t distribution or t-test. When you go to t-test, then it asks you where your data is. Array 1 means, okay, sample 1. Then array 2 means sample 2. Okay. Then tail, okay, which we talked about. So we did this as 2-tailed here, and type. Is it a paired or not unpaired? This is unpaired, right? So we will take, if it is unpaired, we'll take 2 here, 2 sample, sorry, yeah. Okay, and what I got, oh no. Okay. All right, and then you get the p-value. P-value basically means is the probability. Is the probability that that there is 63 point. If you multiply this by 100, you'll get 63.58% probability that the data is. You check the randomness. So you're saying this is like there's only 63.5% chance that the data is random. Okay, which is we want 5% probability of data being random, and then that means we are clearly looking at the decision, which is 5 step. What is it? We want 95% probability that the data is random or not random. We want, and here only 63.5% is random. We want only 5% random. This is too high. So obviously you have to decide that, yeah, there is no effect. So you reject the you accept the null hypothesis that there is no effect. That means essentially there is no effect of any fertilizer. These are just random ones. But again, how, if you want to just, you always look at your p value that you calculated, and if the p is higher than your critical value, which is 0.5, which is 5% critical level, if it is more, then you accept H1 null hypothesis, which is that there is no effect. But again, we must remember that we are not talking about this sample that we have. We are talking about the population. Based on this, we're trying to make a statement about the population. So probably in the entire garden, in the entire population, this will have no effect at all. Does that make sense?
Yes,
so
sir.
similarly, let's say another example. Let's say you introduce fertilizer C, fertilizer B, you do the same thing, right? You then take this is also again unpaired. Why unpaired? Because there are two sets of plants, not the same plant, which was first applied C and then applied B, or the other way around. Two sets of plants, so they are not paired. Unpaired, again, I have done what do you call a two-tailed one, neutral statement, and the process is the same. So if you calculate the p-value, if you see the p-value here is 0.3 multiplied by 100, 3.18% probability that the difference is random, and we want less than 5% random probability. That means the opposite is true. That means you reject the null hypothesis, which states that there is no effect. The data is insignificant. So we say that, okay, we will go with the H1. That means there is significant effect of the fertilizers.
Sir, should we not be comparing with the T table, sir? The calculated T tables?
Yeah, T table, that's what I said. You know, we are not doing the T, we are not finding out the T values, because the moment you go to T values, it becomes very complicated, because then the student has to spend a lot of time in calculating first the T value, and then judge it based on the degree of freedom, look at the critical value. Yeah, and it's not necessary. And every DP student has a calculator, GDC. Even GDC gives you the P value. So if you take the root of P value, this simple it is. Just see if your P value is less than 0.5. If it is less than 0.5, that means there is significant effect. Okay, and then you accept H1. But if you go down the T route, then you have to look at the table and all of those. So I don't really have a reason why ESS student should do that. But you know, if for math student, I would prefer the student to do that, because then he is able to show more mathematical understanding, which is the focus of mathematics IA.
Sir, if we have, say, 6 fertilizer types and we are applying them on these 11 plants, so when we compare, say, fertilizer A and fertilizer B, or C and D, are we going to be like doing the t-test for all fertilizer types in pairs, comparing A with C, B with D? How do we go about if we have 6 fertilizer types?
If you have more than 2, like if you have 3, then you can do the something called ANOVA, another test, which we are not discussing. But if you have more than 3, then you have to resort to chi-square, because you can then deal with more groups. You can make more groups. But t-test is specifically for 2 samples, and so, you have 1 sample also. But yeah, I haven't. I mean, there is 1 sample test, but I haven't. I'm not discussing. But if you want to know, I have one for 1 sample test also. But I thought nobody will be interested in 1 sample.
So last year I did ANOVA test with my kids, but then I also did the TEAS test, which means I repeated the entire thing, which was not required. ANOVA test was good enough for the 6 fertilizer types. There was no need for t-test, which I did.
But again, it will depend on did the students IA had a situation where you had to take a decision between two?
Yes,
if yes,
I wanted.
then it is
yes.
perfect. Yeah. But
Yes.
if you're looking at more than, like, if you have ABCD, ABC, then like the 3 data. Are you more than that, then again a different one.
Right.
So it again has to make sense in the context of the data. But
so ANOVA will not specify which one is the best one, but it will bring about a difference. It will highlight the difference between the fertilizer types. Before bringing about which one is the best, we need to use the t-test, right, sir?
Yeah, I mean, in the other way of looking at it is that if you have largely 2 data,
yeah,
in one sample also you can apply one sample t-test, but if you have 1 or 2, yes, t-test. More than that, then t-test is not going to work.
Right, sir. Thank you.
And these are the things the students can also justify, when they say, okay, ANOVA, right? Why? If the students say that, look, I have more than 3 samples, I can't apply t-test, so ANOVA, it's more analysis, so he's justifying. Right. Okay. So this is the third example where now this is a case of paired t-test, which we explained. Now you have 11 samples, and you the first you observed without applying fertilizer B, then you applied fertilizer B, and of course, so it is the same plant's growth that you are measuring, once without any fertilizer and once with fertilizer. That's how they are paired. And again, it's the same process. So I haven't put it into step 1, step 2, step 3. And again, whether you want to do a 2-tailed or 1-tailed, it depends on what is your notion. Have you already decided and then testing the hypothesis, or you want to see how things go on that one? Right, where we are now ending t-test journey. Any questions that I am in position to answer? Okay, correlation. All right, now let's expand. Let's say, okay, we have the total height of all these 20 plants, okay? And then let's say we have pink flowers and yellow flowers, right? And then what we're going to do, we are going to see what if there is any correlation first between the height of the plant and the number of pink flowers it is producing. And then in my mind, I have taken an example of a plant which can produce both flowers. Like one plant can produce both pink flower and a yellow flower, okay? And which Guru says that, yes, this species can produce hybrid manipulatives, can produce, one plant can produce, okay, but that's not important. In correlation, what we see, which is contrast to t-test, here you try to see if there is a relationship between 2 variables. It's now not the difference, it's whether there is a relationship between 2 variables or not. And again, you don't need any package, you don't need any calculator. If you want to find out correlation, again, it's simple. Go to function. Here you go to statistics. Click function. What do we need? Correlation. Let's start looking for C. Correlation. Correl. Okay. You double click. It will ask you where is your data 1. So let's say our first data is height of the plant, and the second data is number of pink flowers. Okay, and it gives you the correlation. And the second one, which is 0.58428. Okay, and then we checked if there is a relationship between the height and the number of yellow flowers it is producing, and then you see the correlation is 0.8978. So let's look at the first example. So what does this Again, student can use the formula, but I don't see any reason why. I recommend that students should at least first do the primary analysis using a graph. It gives them more opportunity to talk about or justify what they're doing. So, so you can sketch this graph, which is called scatter plot. Then you can already see that the data are more or less close to each other. You can't, say concrete anything about it, but you say, okay, there seems to be some relationship because most of them are around each other only. Okay, then you need the correlation coefficient value R to say anything more concrete about it, which is, now you have a table. This table tells you whether if the correlation coefficient is positive, what does it mean? If it is negative, what does it mean? And it also kind of gives you an idea whether it is a weak correlation, is it a moderate correlation, is it a strong, is it a very strong correlation, or is it a perfect? One is like perfect. If you get perfect, something is wrong. At least in maths world. I don't know about ESS world, right? So since 0.58 falls in this bracket, so you say there is weak positive correlation or relation between height and the number of pink flowers. What could this further mean, which is the interpretation of the student, is that there is a weak relationship between height of plants and the total number of red flowers or the pink flowers it is producing. Okay, another way of looking at it or interpreting it is that as the height increases, the number of flowers may or may not increase because there is a weak correlation. Okay, that's the idea about it. What we need to be careful here, and I'm sure as ESS teachers, you know, not to confuse this relationship with the causation. For example, let's say in this case where we got 0.93%, like, which is like strong positive correlation. And let's say, what does it talk about? What correlation is this? We are seeing that the total number of flowers a particular plant got and how many pollinating insects it got visited in a week. Let's say you have CCTV camera or you have way to find out. I couldn't think of any other example, so I came out with this. And then I said, okay, you take the data. It's how many insects has visited a particular plant. Okay, let's say you have a way to do that one. And we are now checking if the total number of flowers has a relationship with the total number of insects that visited, okay, that plant. And we see 0.93, which is very strong positive correlation. What does that mean? Mathematical interpretation is straightway strong positive correlation between flowers, number of flowers, and pollinating insect. That means there is a very strong relationship between these two, and that means you can say more pollinating insect might have increased the total number of total number of flowers. Now, here is what the student, as an ESS student, need to then say whether does this relationship actually means that one causes the other, or it's just that they have found some relationship. So if there is a strong correlation, that does not mean that there is strong cause of one affecting the other one. Yeah, so this is from the Hayes Maths books. This is what it says. I lifted it straight from there, beautifully explains the causality or the causation. So before we move to finally chi-square, any question on correlation? And somebody asked at the beginning R square. So R square's explanation is very similar to how you would interpret R. You just square it and you get the value, and your interpretation is almost in the same direction. So nothing much to discuss on that one. Most important is R.
Sir, one
question. Excuse me.
Yeah. About this R square, there is a software, isn't it? And we have to fill in certain things. That was where I got confused actually.
So for which one, sorry?
For this R square, there is a software, isn't it? And you have to fill in the parts to get the the diagram automatically.
Okay. No, how I did the diagrams here with Excel, it's again, so let's say we are going to plot this data. So we highlight both, then we go to insert, then we go to scatter, and we choose the one that you want. You can change the thing, and then you got your scatter plot.
Sir, may I ask a question?
Sure.
Sir, I just want to know where exactly do you use rank correlation? Like what you are talking about, I think is the linear one. Like,
Yes,
can
yes,
you give
Pearson
us
model.
one example of, Pearson? Can you please give one example of Spearman also, if possible? Rank correlation.
Well, see, if the ranks really matter in a particular data. So, for example, here, as you observe from the field, you kept writing this one. No? You started writing the number of flowers, and against the number of flowers, you started writing the number of pollinating insects that you visited them. And it really doesn't matter. In this context, it really doesn't matter which rank, which is the, what do you call, which is the, like, do you want to say that, no, this is my top priority, the one that which has 15. So this is my top one, let's say, this is my top one. Okay, then, oops, sorry, they are related. Let's say you rank them. You said, because for whatever reason, you say that, okay, it depends on which rank wise it is coming. So if you rank them, then you apply that one. Okay? And again, if I have to discuss the Spearman's rank correlation, it's going to be another, maybe in some other day. But the simple thing to understand is that if ranks matter, in order or the priority in which the data is occurring, then you have to resort to Spearman's rank correlation coefficient.
Okay, sir. Thank you.
Sir, obviously the R, which is 0.932, the causation is as you actually examine the flowers being pollinated, as you observe that more number of insects visit, the more number of flowers you get. So can't we actually tell that they are quite correlated to?
Yes.
0.932, because as you see in 21 and 7, and they are directly proportional in terms of if there is no insect, there might be even zero the number of flowers that might result in. So we actually tell that yes, both are the both of these have a strong correlation of 0.93, and then one causes the other.
Yeah. This is a decision I couldn't take as a maths teacher. So this is a decision which the ESS students or the ESS teachers will take. That correlation is big. Okay, that means there is a relationship, and it actually makes sense in the context of ESS. So in this case, as you are rightly saying, the more pollinating insects is visits, the chances that the number of flowers will be more is high. So yeah, it is safe to conclude with this justification with ESS theories that you have. If you have ESS theory which says that, of course, the more pollinating insects a plant or a garden has, that there are chances that there will be more flowers. So, and if the student can state that argument, and then they say, yes, in ESS we have this theory or concept, and hence even the R shows that there is a strong relationship. Therefore, I conclude that yes, the number of insects, pollinating insects, actually caused the total number of flowers. But if it is not, then you don't. For example, even if in this case, height and plant, a number of red flowers, I don't know, is there any relationship? So even if you had, sorry, what is it? R2, yeah. So let's say, what is this about? This is about correlation. Okay, sorry, R3. I think I had another example. Right. Let's look at R1, which is about the correlation between height and the number of pink flowers. Okay. Even if you had a student got 0.9 something like the previous one, very high correlation, then would you still conclude that height really makes more pink flowers to blossom, or there is no relationship? So that's the decision ESS student or ESS teacher has to make. So the point is that low correlation does not automatically mean that one is not causing the other one. High correlation does not automatically mean that one is causing the other. You have to look at the context in ESS. Thank you for asking that question.
Yeah, actually, what Mr. Shantanu is saying, I believe Mr. Shantanu is saying that, okay, whether we have very high correlation R value, even then in ESS, as ESS teachers, we know that a single variable will not make the product so much relatable to the variable which we are checking. Here we are checking the number of flowers with the height. So there might be some other variations, maybe shooting at certain point of height. There are some shoots happening. After that, only pink flowers are coming. Now the previous where R was 0.9, that means it doesn't always mean that only by visiting of the insects has caused that high number of flowers. So as ESS teacher, we need to be aware of various other parameters which are affecting the product, which are affecting the result, which are affecting the R value. So that shows that if the students are able to justify, give various reasons for high value of R or low value of R or medium value of R, it makes their analysis more deep. So as teachers, we need to be very careful when they are analyzing. They should not assume that 0.9 is high correlation, so the causation is with the same variables. We should look in the periphery also. So that is the key where as teachers we need to guide them. What could be the other factors which are having high R? That's what I want to say. Thank you.
Right. Perfect. For maths teachers, it's like, yeah, this seems to be relationship, and you say, yeah, if it is so high, yes, it should. Pollinating insect must be influencing thing. Yeah. But yeah, for ESS teacher, biology teacher, you need to look at the whole context. Perfect. Thanks for your input. Shall we move into chi-squared?
Yes, sir.
Yes, sir. Sure, sir.
All right. So even in chi-squared, what I have done is took the route which is less painful. Same 5 steps. We are only calculating p-value. We are not calculating chi-squared value. Because if we go and start doing chi-square value, then again, this will put off your ESS student, because they know they are doing a lot of maths, and they are not going to be assessed on maths. What they are going to be assessed on, at least in my understanding, is how they decide on a particular mathematical theory, whether they want to do chi-square, t-test, or ANOVA, or correlation, their rational, their data, and then how they are interpreting the result. So again, for chi-square, I have taken a simple step. You can use this website. Okay, so if I click this website, okay, first, before we go to the website, let's see. Let's say we have the same data. Okay, now we need to, let's say you decided to see whether height and color are dependent on each other. Like you see in t-test, you checked whether the data is random or not. Is there a difference or not? And in chi-square test, you are checking whether one is depending on the other one or not. I don't know in ESS context how much these two are different. If anyone wants to elaborate on that one, I'll be very happy. But for mathematics, they are different when we do the mathematics. In your ESS context, I don't know if, okay, for t-test, it's like whether one is affecting the other one or not, or how random the data is. That's what you check. And in chi-square, you actually check whether the two variables are depending on each other or not, whether there is a dependency or not correlation, or if they are just independent, whether they're independent or they are not independent. Not independent does not automatically means dependent. So you need to probe more into it. Again, for ESS biology. For mathematics, it works just fine. So let's say this student says that he wants to check whether height and color has any dependency or not. So null hypothesis set as height and color are independent, and the alternative hypothesis is set as height and color are not independent. As simple as that. Most hypotheses are same like that, at least in maths world. So in ESS world, you can have, depending on what you are saying. But this is a very simple example just to understand how you do it. And then again, you have to decide on significant level, which again, across all classes, it remains 0.05. And now this is what we have to prepare, the contingency table. So this is part of your processing. This is the contingency table that you need to prepare before you apply your chi-square test. And if you are doing if you're calculating the chi-squared value, then you have to make another table called expectancy table. And then again, you have to apply formula, do a lot of data processing. Here, I have just kept it simple. Okay, we will process this data that you see, and we'll put it into a contingency table and find out the p-value for chi-square test. So how I have made this data? So I said, okay, what I want to check? Color. So what are the color? Pink or red? Okay, pink or yellow. These are the two types here. And then you want to check if there is any relationship with height. So I could have taken more of this grouping, but I just took 0 to 18 centimeter and 19 to 13 centimeter. And then I looked at the data. All the red ones are 0 to 18 centimeter. I added them and kept here. All the yellows that you see here, they are all yellow flowers between 0 to 18 centimeter height from a plant which is 0 to 18 centimeter height. And 82 is number of red flowers from plant which are higher than 18 centimeter. And 129 is the total number of yellow flowers which comes from plants which are 19 to 32 centimeter height. In this table, everybody needs to prepare from your raw data. So this is your data processing. Once you have, then you perform the chi-square test. And as I said, we are taking the p-value route. Simple, sweet. Just see what is the p-value. The same applies. If the p-value is greater than 0.05, then you accept null hypothesis and reject. Right. So how we can do that? So let's go to this site. It's very simple, friendly. Are you able to see the screen that I got? A new website opened?
Yes, sir.
Can everybody see that? Okay, cool. Ideally, if you want to do it what is it, 0 to 18, you can put, or you don't put, you can just say 19 to 32. Just naming them. Let's say this is red and this is yellow. Even if you don't name this variables, it's not going to make any difference. So you go to next. And then you put this contingency table value here. So what was our data from the contingency table? Okay, hold on. Oops. Okay, so it was 13, 14, 82, 129. 13, 14, 82, 129. 13, 14, 82, 129. Okay, that's all you need to do. Then you go to next. You choose the significant level. By any chance you are selecting a different significance level, choose that, otherwise 0.05, and calculate chi-squared. Okay, and then it gives you the chi-square statistics and it gives you the p-value. What we are doing is we are looking at the p-value. it also already gives you the answer. It says this P is not significant because, sorry, where is it? No, not significant. Sorry. No, this result is not on the P value. Okay. So we have got the P value as 0.035, which means, where is my Excel sheet? Okay. Yeah. Which means this is higher than 0.05, which means if you multiply this value by 100, so there's 35% of the chance that this is not going to be in that zone. But remember, this is not normal distribution, but the same idea you can apply here. So if it is greater than 0.05, then you accept your null hypothesis. That means height and color does not depend on each other. Same process. Another example, let's say now we are looking at number of pollinating insect and the color. Okay, is there any relationship between the color and the pollinating insect? Maybe if different varieties of pollinating insect visit, that might influence what color the plant flower will be. Then again, you do the same thing. How many pollinating insects visited that far? I chose between 0 to 3, 4 to 7. And then again, see how many red flowers are from plants which are from which was visited by 0 to 3 pollinating insect, and likewise you make the contingency table if these are the two variables you're trying to test, and then go through the same process. Now we see a P value which is 0.014, which is less than 0.05, and that means most of the data are there. It makes sense for you, so you reject the null hypothesis. That means the pollinating insects, number of pollinating insects also influence, or there is they are not independent of each other. Whether they are dependent or not, as ESS teachers, you will take decision like you took decision in correlation. There is high correlation, but you will take a decision, the students will take a decision in ESS or biology context. Does this really mean that, or there are other parameters which influenced it? Any question on chi-square?
So can you just get that screen once more?
Sure.
I just want to write down that step 5. Yeah.
Would you, I mean, I'm perfectly fine sharing this Excel sheet also so that you can see which formula is there so that you remember. I'm perfectly fine. I can share this Excel sheet also.
Okay.
Yes, sir. Many teachers are asking the Excel sheets.
I was just copying as you were talking.
Yes, yes.
That's okay.
Right. I think this is the end of this whole maths and ESS journey. So if you have any questions right now, or we can just say bye and
Sir,
see.
We will never say bye. I have a question. Sir,
Teachers, you can
in
go one by one.
ESS, sir, we use, when we write an RQ, we generally use a term called to what extent. For example, we write to what extent say, for example, the height of the, plant is a color, something like that. So when we write to what extent, do we generally we try to justify with a significance level, whenever we find. So does this RQ also talk about the statistical model we are going to adopt, or it is independent of the statistical model when we use the term to what extent? Sir, am I clear with my question?
Other ESS teachers will also give their input. In my understanding because in maths, we don't have a research question in maths IA, but from my extended essay experience, I know your research question, you answer your research question through your different reasoning. So if you start a research question with to what extents, perfectly fine. but then you kind of answer it with this statistical test, if at all anyone is interested. So I don't right now see any relationship whether if you start a research question, because your research question is not the hypothesis, but if your research question is also the sole hypothesis of your IA, then you got to really see how you phrase that. Because when we normally phrase the hypothesis, we don't say to what extent. Research question can start with to what extent. But I leave this floor open to other ESS teachers to comment on that.
Yes, sir. What you said is correct. Correct, sir.
One more thing, sir. What you said is absolutely correct, because in my latest workshop that I attended, there it was said clearly by the workshop leader that to what extent is a very open-ended question. That phrase is used for open-ended questions. So, but in ESS, the RQ has to be very focused. It's mentioned. So in that case, we should be avoiding to what extent unless we are mentioning the statistical analysis that we are going to focus on or what the variables are. So unless the RQ is very clear and specific, we should be avoiding that phrase.
I don't see that there should be one chance to just drop it. To what extent, if we are doing it either by correlation, regression, or ranking analysis, just we have to revisit the RQ to satisfy and justify that we have, to some extent, how we have explained our RQ. So, but it should be in the mind of student and the teacher to guide that, okay, we have to revisit the RQ to explain to what extent we are able to explain our hypothesis. And you know, the RQ, the question in the RQ. But hypothesis and RQ are not separately said very explicitly in ESS. We can have RQ and we can also have hypothesis, but in TSM or in the guide is never mentioning about whether we should have both or one, but RQ is one. I mean, it is there, essentially there. But hypothesis, it is not mentioned that we should have hypothesis. So T-test and chi-square test are not mandatory kind of a thing. But if you feel that ESS child has got that much of sample data and we need to establish the covariance and the variability, then we decide the test accordingly. So that is what ESS teachers need to take a decision on. Thank you.
And one thing more, when you're saying to what extent, when you're analyzing, you can always give your comment that to what extent you really think whether the hypothesis was truly correct or whether you agree that it is with some reservations or not. Like if you're talking about correlation, whether it was a strong correlation or a weak correlation. So it's not very necessary to omit that to what extent. I personally feel it shows that you're more focused actually when you say to what extent. You start the question by that.
I think, again, you know, in maths, we don't have a research question, and then, so normally we have aim, and in the aim, the student can write to what extent and start. And then what the student tries to do is that whatever question he asked at the beginning, he uses different data, different method, different mathematics to
substantiate.
Substantiate. And then at the end, he says, to what extent, to no extent, or to a great extent it happens. So
exactly.
I would view it like that.
It holds good for all the IAs. That is including your TOK. That is what they say. That you either you agree or you don't agree, or you agree with reservation or you don't agree with reservation. 4 options. And then you analyze why you are saying this.
But I think I'll also say that when I discuss with the ESS teacher and the biology teacher, not just in my school, often science teachers talk to maths teachers. So the problem or you need to be careful only if the research question is also the sole hypothesis of your of your
that
investigation.
is a matter of concern. Yes.
But if you have many hypotheses or many correlation testing and everything leading to answer the research question, then it's okay. But if it is so,
Leena madam, go
actually
ahead.
choosing the best statistics test is most essential for your experiment. That is what I would say.
Sir, actually what I feel is like, when we are using the phrase to what extent, I feel my students are getting more freedom that they can justify based on the statistical data they are getting actually. So that is actually, I think that is the best phrase that child can go for.
Yeah. I have a different question about the t-test and the data points. So when it's not, you said you're comparing two variables.
That's the way it is
so
done.
Is there a minimum data point we should keep
for t-test?
Yes, of a t-test and our test or correlation. Is there a minimum data? Because usually what happens is a student conducts an experiment. So, and he's repeating the trials like 2 or 3 times, 5 times, whatever. So, but basically you take an average, so data points are 1 to 5 only. So you are taking an average only of 5 data points. So,
yeah, you see, normally in maths world, t-test is applicable. I mean, you should have at least more than 10 sets of data, in one sample. Then t-test makes sense. Otherwise, yeah. And for correlation, more data you have is great. Like the more variables, more data you can plot, and you can more confidently say that there is a relationship between two data. And for chi-squared, one need to be careful. If your data is less than 30, there is a problem, because you saw in the contingency table, you have to, whatever data, they get really squeezed into a tiny table. And then when if you apply the normal way of how you calculate chi-square, then after that contingency table, you will also calculate something called expected value table. And in that expected value table, you will still get this 4 data out of the data. Then if anything is less than 5, then the chi-square test will not be applicable, right? So you need to see that one. So normally chi-square, I advise students to go beyond 30, then only a chi-square test makes sense. If you're applying correlation, if you're trying to find out correlation regression, yeah, plus 20 is better. T-test, at least get some 10, 11, 12, 13, 14, 15 data.
Any doubt? Next.
Sir, in my opinion, 5 into 5, 25 samples we are doing for particular lab, because 5 different variations and each time it is repeated 5. At least I make my students do that.
Yes, you're right. At least in the guide that says.
Any other doubt, teachers? Okay, good. That means we are finally come to the end. Teachers, please note you will be getting recording, Excel sheet, PPT, everything. So you need to wait. And I request everyone, please share your feedback on the ESS WhatsApp group. That will motivate others. Shantanu sir, we have some teachers who want to give their experience. So first I'll go with the Shibha madam. Shibha madam, please share your experience.
Good to see you. I didn't see you.
Sir.
How are you?
I didn't bother you in between. I joined 5 minutes late. I wanted to say hi at the start. How are you doing, sir?
I'm perfectly fine, thank you.
I'm good.
Yeah,
I mean,
it's
I never got
2 pathways teachers.
Yeah,
in the same meeting.
And it's all thanks to Guru sir to organize all these good sessions where we all are benefited. So I mean, when we were in school, didn't get much of time, much of interaction in this way. So now it was more of a of course more of a connect. So first of all, I would like to really thank you for taking out time from your busy schedule and be with us and really face we non-mathematicians actually. So I know as a bio background and ESS teacher, I know how much math scares me. I can't really tell you. So this was one of my own takeaway from this session is that I really got comfortable with that part, which my students, they at times they come up with the questions that I'm applying the statistical test, but then I as a teacher, I'm not able to really give that that justification, yes, you are going right or wrong or why. So that this session basically, and I'm really thankful the way you have really played the questions fielded on you, being a non-ESS teacher, non-bio teacher. You were simply here to clarify our math doubts, and we took you as somebody who should be answering our ESS queries also. And I hope in this process, you also must be really benefited. I'm sure you can now go through an IA from ESS or bio also well.
I will not take a chance with biology, physics and chemistry. Okay, biology, ESS never, geography never.
Sir, I mean, you did a wonderful job. I mean, I can totally understand your math background, but still, I mean, you had really planned the session well, and we all, we all are benefited. So it is in different ways we are really benefited. Like for newcomers, it is just an understanding where we need to apply, what we need to apply. And for people who have been doing it forever, and I mean, for many years, they can also still, just be a little more revised about things, that how these things can be bettered. So thank you once again from our ESS group, and thanks to Guru Sir for planning such great things. Thank you.
Thank you, Shibha Madam. We have next another Archana Madam. Archana Madam, please go ahead.
Good evening, all of you. First of all, thank you, Guru Sir, for again arranging a fantastic session. Guru Sir keeps on, making our weekends really informative. So, being a newcomer, I just joined. I'm a biology teacher, but this year I'm also teaching ESS in my school. And thank you, Bhowmik Sir. It was really a very informative and very interactive session, I would say. This is something, bio teachers or ESS teachers, they're not very comfortable with mathematics part. It's always a hiccup, whenever we want to guide our students, we need to be very confident about it. It should not reflect that we are not aware or we are not very sure. But I think your session has given us that confidence, like how confident you were with ESS. I think that's how we have to make relationship with mathematics now. So I think you have wonderfully taken the ESS and integrated your understanding, the wonderful example of fertilizers. And I think, it was really making us comfortable. And I think the basics, what I would say for statistics and how we should take our students, depending upon their caliber and how much they can take it for math, that was really wonderful to know. And I think from here onwards, I'll be much more confident when dealing with the math part of ESS, whether it is IA or EE. And thank you, Guru Sir and Sir Bhowmik Sir again for the wonderful.
Thank you, Archana. We have a last teacher. Rupa Madam, please go ahead, Madam.
Good evening, sir. Good evening, all of you. I was desperately looking for this session. The best part of Santanu sir's presentation was he started with mean, which was very simple thing. Like, so it was not at all scary, and we were, we could go step by step, and we could understand the complex kind of mathematics. It also projects that, of course, we have learned a lot, but still mathematics is an integrated part of our experimental sciences. So Santanu sir, we will again look forward to your second session. This is just a beginning. This is not the end, because we have just begun to, we have started learning how to use mathematics. So we will look forward to more and more sessions from you. And thank you, Guru sir, for such a wonderful session presented. Thank you, sir. Thank you.
Thank you so much. Yeah.
Guru sir, 1 minute. So teachers, I will be grateful if you share your experience also on the ESS WhatsApp group, so that will motivate others. So I know, sir, you have how much that Sunday is a very busy schedule. So you don't know people are attending from Africa, and there are 3 teachers, sir. Today they are going for surgery, sir, but they are attending this session from the hospital, sir. Okay, they are attending. So you should know how much importance of these sessions are. That's our ESS WhatsApp group. This kind of group you cannot see it anywhere, sir. You can see only in this ESS WhatsApp group, sir. Sir, your final words, sir.
No, I'm really thrilled because, you know, as I said at the very beginning, I'm already, before I presented, I was the beneficiary because I had to also revise. And then when you do these things in your classroom, then it's a different teaching. But then, you know, I thoroughly enjoyed researching about plants, flowers. I WhatsApp Guru, does this plant give 2 kind of flower? And he's like, in my understanding, it is. Okay. So for me, I also thoroughly enjoyed this whole idea of how, the whole process of how I can integrate it in the context, staying in context of ESS. And I took a informed decision that if I take out, maths teachers are known to take out these formulas, this horrible looking formulas. If I take out t-test formula, if I take out chi-square test formula, that's it, done. Not just teachers, it puts the students off also. But I have to do this job because when I'm teaching my students and they're doing IA or anything, they need to do this. They need to know that. But ESS student, in the best of my understanding, they don't need to know that. So I thought, okay, p-value is the best way. Take an Excel sheet. Everybody almost knows how to deal with an Excel sheet. Take the p-value, and then it is not that you are, if you look at my Excel sheets, there was almost no mathematics involved, isn't it? You write your hypothesis and all of those data, 90% full of data, hypothesis and everything. Where is the maths? Just a click of a button and you select that, you have the p-value. And how easy to, reject or accept a hypothesis based on the p-value you got, right? So I know as ESS teacher, what you're saying is that whether you will be selective in who you guide in terms of whether they should apply the statistical test or not. But I, as a maths teacher, want to encourage you that let's do a critical value of 5%. Let 95% of your student apply t-test. If it is this simple, and if their IA has situation, not like forcefully, okay, all of a sudden after 3 pages says, now I'm going to apply t-test. Why? No relation. If it requires, if the data or the nature of the investigation requires that this do suggest, and I would say that do it, collaborate with your maths teacher, because if you when you do the unit planning, in which order you're going to sit, always try to convince the maths teacher that do all the statistics related thing at the very beginning in the first year, so that the student has all of that. Okay, so this is an ideal situation giving. Okay, let's say maybe if not this academic year, or maybe this academic year we just started. Ask your maths teacher that can you do the statistics first in your scheme of plan? Maybe finish it in the first semester, which is possible. It doesn't need particular maturity. For calculus, you need particular maturity. For statistics, you don't need. Let them do that. They will use all the formula and everything, and students will hate them. And then when they come to your class, you just take your Excel sheet out and you tell them, look, you got the data. This is how you do it in 1 minute. They will love you. So to end this, I think I would say thanks for your patience and thanks for joining. I thoroughly enjoyed how ESS teachers, all of you were, interacting with me, and I am posting here my LinkedIn link. I'd be very happy if you connect with me. Guru has already posted that I'll be presenting. You can go and comment there. Let's connect. Let's stay connected. It's a wonderful world. IB world is anyway small, but this was the old saying 10 years ago. But now we are growing, so let's stay connected. And wish you all the best, and I wish you well. People who are in the hospital, I hope everything goes well with you. And stay safe. Thank you so much, Guru, for inviting me.